Yo, I figured I may as well try and do work through practice problems with calculus and stuff. Excuse my coughing and stuff. I'm just straight up sick. But yeah. Limits are, again, if you guys had watched my previous video, like the easiest concept in calculus. It's the first thing you learn, and yeah, I don't know what else to say, but we can work through the problems, each one of these problems, pretty easily. If you know algebra, you should be able to solve a limit pretty easily, even without looking at a graph. This is going to be some of the problems you might see in calculus, but yeah. So let me get a cough drop real quickly first. I'm assuming that you guys are... I want, you guys to sort of work through at least the first 3 problems in your head, because I think it's pretty easy, the first 3. The last 3 probably require a little bit more work. You might actually need paper to figure that out. But I'm going to already assume that you've solved it, the first 3 here, because it's really not that hard. You could have easily paused the video as well, so let's go through them. So the first problem, the limit of 7 as x approaches 3. Probably doesn't look or sound quite right, I guess, because the way I learned it in class as well, you probably learned about limits, like the limit of f of x and stuff, yada yada yada. This is f of x. F of x equals 7. Whatever you input for x, it's always going to be 7. As x approaches 3 here, f of x is going to continuously approach 7 because it's always 7. It's just, if you look at it from a graph form, straight up, it's just a 7. Just goes infinitely towards that and stuff. So the answer is literally just the limit of f of x, if it's equal to 7 as x approaches 3, is just straight up 7. You really didn't even need to think much there, but yeah, this is just f of x, just like, I was kind of confused. I feel like that's one of the stupidest things to get confused about, but honestly, I was just stupid enough to just not realize that. I don't know, just the formatting and stuff, you kind of just... I think that the overall thing, how it looks, is probably why people get confused and junk. The limit of 5x plus 11 as x approaches 12, you could plot it on the graph. You could literally straight up put 2 into x right here, and you get like 10 plus 11, and you get like 21. Isn't that the funny number? But yeah, there you go. That's the answer right there. You can literally straight just plug in whatever number you want in there. Pretty sure the graph is like 11 here, and then we have like a really steep graph. Got like 2 here, and that's like 21. Now this, I'm pretty sure you should know that that's an absolute value symbol. Basically, I mean, absolute value is just the absolute value. Like, I don't know how else to explain it. Fuck me. But again, you can just straight up plug it in. You just get 0 out. Not much thought there. Oh god. Fuck my throat. But the next problems here, probably, I'm guessing you guys are more confused about, especially if you're just completely new to calculus. This is probably the stuff you're gonna see most of the time in your problems. These are like the easy peasy questions. And I would like you guys to just straight up plug in 3 into this and 1 into this. And you can also plug, I mean, I kind of want to save this for later, but you can do that early as well. But if you plug in, you know, what the limit approaches into these functions, you should probably get like 0 divided by 0, right? Hope you guys got that. And this is, and if you plug 1 into that, you should also get 0 over 0. And I guess I should probably work through it bit by bit, actually. I mean, if you plug in 3 into there, you get like 3 squared minus 6. This ends up being a 9, by the way. Minus 3. And of course, all that cancels out into a 0. The bottom there, you also get 9 minus, plug in that 3, 30 plus 21. Both of these add up to 30. Minus this out with that. And, you know, you just get 0. This just ends up being 1 minus 1. This ends up being 1 minus 4 plus 3. And yeah, basically 0 over 0 again. But the limit technically exists. I mean, I don't mean like technically, like, I don't know what I was trying to go here. My mind's completely fried. I'm not even in the right state of mind to teach. I'm just completely empty-headed. Me. Alright. The limit exists, and well, I guess I should probably like erase that little bit there, just to sort of accidentally messed up that. Oh well, who cares? But I'm assuming that you guys already know algebra, and I'm pretty sure you guys can factor this and this into, like, you know, x minus 3 and x plus 1. You can do that for like this here and that there and that there. I'm gonna rewrite that down here so that way it gets easier for me to deal with later. I'm assuming you guys probably already paused that and already worked through that, so let me just quickly do that in my head. Somehow I can do this while I'm still empty-headed. Wow. This is x minus 3 x minus 7 for this, and I guess we'll do both of these at the same time as well. This is literally x plus 1, x minus 1, and then we have the bottom here, x minus 1 and x minus 3. Now if you notice, these here can cancel out, and I'm pretty sure you guys have learned in algebra that, you know, you can basically simplify the equation or something into something like x plus 1 over x minus 7, comma, like x cannot be equal to 3 or something, because, you know, this is basically equal to x plus 1 over x minus 7, except this is defined at 3. Even though, like, if you plug in like 3 here, it will just end up being a 0, and, you know, just it's not determined. So like these two things are like the same thing, but like you have to include this in order for them to be the same thing. But I mean, personally, in school, I have not ever given a crap about that ever, because to me, this and this have always just been the same thing to me. It worked out in the end. Just keep, I mean, even you don't even have to keep that in mind, because honestly, for me, even ignoring that, it just works out in the end. So like, unless like you know, you find one of those weird math tricks where, you know, somebody manages to pull 2 equals 1 or whatever, you typically don't, you know, that's usually when you keep in mind something like that. But like, just straight up, doesn't really matter. These are literally the same thing. Just plug 3 into here, and then you get 4 over negative 4, right? So the limit of f of x, where x equals that entire thing as x approaches 3, that is equal to negative 1. Now, very sure if you guys go to your graphing calculators or use the online graphing calculator, type in that equation, this entire equation here, you will probably find out that, you know, at x equals 3, it's basically approaching negative 1. Like, if you use decimals or something, it will probably say undefined at 3, but like, this is where it should be approaching, like in that whole, that's where the hole should be at negative 11, if like the graph were continuous at that point there, you know. Again, and then here those two cancel out. We just get equal to, like, you know, x plus 1 and x minus 3. So then, of course, you know, then we also have to include this little thing where, you know, x can't be equal to 1 or something, but I don't care. It's too annoying and really pointless to the entire thing. Like, you know, it's not really that important in the problem solving scheme of things. So, you know, now you just plug that into here, actually, since, you know, both of these are practically the same thing. You get 2 over negative 2. And I feel like I actually made a really dumb equation, because not every limit with the whole, you know, that not every limit with a whole, you know, design like this is going to equal like -1. I think I messed that up. I probably should have made better equations. I made these equations on the spot just like a few minutes ago, just for this video. And I really feel like I should have chosen something better. I probably could have chosen something online, but I wasn't sure about like the copyrights and all that crap. And of course, if you have plugged this in here earlier, you guys probably would have noticed this is basically 4 plus 10 plus 6 equals 20 over 4 minus 8 plus 4 equals 0. This is 20 over 0. This is undefined. Oh no, what does that mean? Well, if anyone had worked ahead and tried to factor this, you would find that these would not factor out. I'm pretty sure they won't. That should be it. X minus 2, x minus 2. Yeah, that should be it. None of these actually cancel out, so like this limit doesn't exist. So basically, how would I put this? In order to solve limits in general, I've always just sort of, you know, I don't know how else to put it, but like, if if you're given like a limit of f of x as x approaches, something, just call it a, you can generally just plug a straight in, and if it ends up being like an actual number, like, I don't know, just call it like 7 or 5 or whatever, that's just the limit. If you get something like 0 over 0, then you probably have to do more work to find it, you know, like this and stuff. This entire area here, you know. But if it ends up being like some weird number at top over, you know, just undefined or whatever, then the limit probably doesn't exist at all. In fact, I'm pretty sure there is no limit. That, you know, if you plug it in, if you find it undefined, you know, it just doesn't exist. And that's how you solve limits, I guess. It really isn't that hard. I'm probably explaining it really badly, but like, given any problem, just like I don't know how, like, just a limit of any f of x as x approaches any number called a, just plug it in, see what you get. Actual number, congratulations, you figured it out. If it's a 0 divided by 0 indeterminate, basically, probably gonna have to factor something out. In fact, something you might find, I guess, is like probably sine of x over sine 2x or something like that. As x approaches like, I don't know, pi. And you basically, if you already knew trigonometry, then you'd use trig identities and stuff like that. you technically don't need to know trig in order to like pull up a sheet of trig identities and just like switch things around. Like let me just straight up search up table of trig identities, because I have not memorized. I completely forgot all of it. Like in class I remembered all of them, but like after I passed class I completely forgot 100. I don't even, nope, not even, I don't remember a single thing. So this is the thingy I found. Guess I should do that in like a later thing. Ta-da! Here's the thing I just pulled straight from DuckDuckGo. I don't know, like here you basically just like you're looking for like you're trying to figure out what to cancel and stuff. This is the thingy, I guess, you know. This is basically equal to the limit of sine of x, gonna remove that parentheses because it's just a pain in the butt, to sine x cosine x, because the sine of 2 of variable equals 2 sine variable cosine variable, or a value, you know. As x approaches pi, you can straight up cancel them out or something, and then you can get like 1 over 2 cosine x. Well, technically for this problem, since we're approaching like pi or something, yeah, no, if you plug in pi for this, you'll just straight up get like 0 over 0, because yeah, sine of pi over sine of 2 pi, that's just 0. That equals 0, and that also equals 0. If you haven't learned trig already, please do, but you probably don't need to do like learn the entire thing. Just like I don't blah blah. Oh my god. I genuinely should not be teaching at all, because I am stupid. Yeah, no, I am the ace. I do super well in math, but god, I suck at teaching. I don't know what else to say, but like, you know, basically you might see something like this in your calculus class. You can't skip pre-calc and skip trigonometry, or at least some portion of it. And where you basically simplify it because you got indeterminate form, and you know, once we plug that in, we got like 1 over 2 cosine x, 2 cosine x, cosine x at pi equals like 1, I believe. No, that's -1. So the limit ends up being like, should probably also keep that there because we haven't really gotten rid of the limit. So basically, like, we end up with the limit as x approaches pi of 1 over 2 cosine of x. That's, we ended up there through some, you know, like factoring out and doing trig identities and stuff like that. Then we can try and plug in the thing again. We end up with like 1 over -2, which is basically just the same thing, but you know. Ta-da! That's 1. But there's also like other stuff as well. Let me pull it up. There was a little thing that Khan Academy had, a sheet of like things to do. Well, you know what? let me just... Here it is. Hope it's on the screen properly. Let me zoom in. Fuck me. God damn it. I'm out of water. Why? Yeah, alright. So basically, in order to calculate any limit, this is basically the chart, how everything works. Khan Academy is basically this how I self-studied it. So, I don't know, maybe check out them instead of me, where I utterly suck at teaching and stuff. But, you know, like I said, you basically try and put the limit where, you know, where, like, you basically plug in the value where, you know, the limit's approaching, and if you get an asymptote, you don't have a limit. The limit doesn't exist. If you get like a real number, actual digit, then you found the limit. If you get like indeterminate 0 over 0, then you basically try various strategies and stuff. I showed factoring. One example of trig identities. Oh, literally use the same one. But there's also like square roots and stuff, which I conjugates. Technically the same thing as factoring. It's just, you know, the x is just a different power. Although. Also, now that I read this, I remember. Sometimes that stuff just straight up doesn't work. Like, it doesn't matter how much you know, try and write it in like a, well, equivalent term form, you know, just try and simplify, factor out things, and use identities and stuff like that. You could straight up just, honestly, just like type in your calculator, just instead of doing all this work here, you could have easily just like plugged in 2.9 and then 2.99, 2.999, and also like 3.1, 3.01, and just get closer and closer to it, because, you know, that's also the same thing. You don't even have to do all this work. You could straight up just type in all that and just take a good guess. But like, yeah, there's also the fact that like you technically could straight up get a limit, or I don't even know. I am so fucked up right now. What the fuck am I doing? This is like the easiest concept. I really don't think anyone should struggle with this. In fact, this really isn't like, you know, the hardest thing. The hard part in calculus isn't really anything I'm gonna teach until like the very later parts, because like if you learn I'm pretty sure if you guys can learn, like, I don't know how to let me just like you guys can easily learn what a limit is and how to evaluate a limit. You guys can easily learn what derivative is, how to do one. In fact, you can even just straight up pull up a table of derivatives and stuff like that. You can also learn how to do integrals with, you know, just all that stuff is actually the easy part. It's really when the class begins to shift into like, how would I put this? Let me just like open up a new thing here. Like, it's when you begin to like experience problems of how to optimize area. Like if you have like a 12-inch by 18-inch sheet of paper, how do you cut it in such a way where you maximize the volume of it using derivatives and stuff, using like different functions and all that stuff, just straight up. That's when it becomes complicated. And then we have like integrals, and we have to optimize volumes and areas and stuff like that, maximize areas and all that stuff. That's when it becomes complicated, like actual application problems, because I'm pretty sure, again, that all this stuff is just plain easy. Again, it's not that difficult. It's just like when you start to apply it, then like limits. I don't think you'll have any problem applying it. This is just plain fucking easy. But derivatives and integrals, I have 100% certainty that anyone who's watching this will have any problems learning it. But like, wait until you get to the practice problems and the applications into real life about engineering and powers and all that crap. That's when it becomes a pain in the ass. And I haven't even actually gotten into the multivariable stuff yet, which I plan to, because that's the entire thing about this video series I plan to do. Just straight up. Yeah. Thank you all so much for watching. I have a coffee and stuff like that if you guys want to donate to me. I cannot find a freaking job at all. Well, I can't find jobs. It's just like they won't fucking hire me. They call me, tell me that, oh hey, we're gonna get back to you later, and then they never do. They never fucking do. So basically, I'm freaking jobless. And of course, I decided to take engineering classes. Math, of course, the most helpful thing for me to earn money. Then again, neither English and a whole bunch of other classes don't help me get jobs either, but like, this is... yeah, no. And I can't even work at McDonald's because they won't even hire me. Like, bruh. That's just how badly I suck. Yeah. But please, if you guys want to donate to me or something, please do. And I will see you when it gets tougher, because this really isn't like the challenging part. This is like the easy peasy part. I hope that I did enough to cover it, but like straight up, I don't know. Just like leave your comments and stuff. If you guys are completely lost or something, then I probably need to completely delete this video and rethink my fucking life. But if you guys are only confused like a few portions and stuff, like you guys understand how to do limits and stuff, but like you don't understand like conceptually why, if it cancels out, why, even though like there's a hole and whatever, like that kind of stuff, I could probably answer that. But otherwise, yeah, thank you so much for watching. I'm pretty sure I repeated that, didn't I don't know. God, I seriously need like, I don't even know. I just need something to get rid of this sickness. It feels awful, man. And yeah, I hope I'll see you guys when I eventually cover multivariable stuff, which I plan to not screw up as badly. Maybe I'll actually write a script for that. I have a few videos that aren't math related. I have scripts written up, but fuck, man. At this point, I'm actually fucking rambling on. Sorry about that. Goodbye.